Welcome to the Explainer. Today, we're literally slowing down time to look directly under the hood of the internet. We interact with the web every single day, right? But we rarely stop to appreciate this incredibly complex, invisible symphony of communication that's happening right in front of our eyes. I mean, have you ever actually wondered what your browser is doing in that split second before a web page appears? You type an address, you hit enter, and boom, it's just there. But between your finger lifting off the keyboard and those pixels lighting up your screen, your computer is having a massive, high-speed conversation across the globe. We're talking pulses of light literally traveling through fiber optic cables, crossing oceans at roughly 200,000 kilometers per second. It's wild. And today, we're going to decode that exact conversation. Here's our roadmap for today. First, we'll cover the client-server model. Second, the split-second journey. Third, static versus dynamic content. And finally, number 4, behind-the-scenes complexity. Section 1, the client-server model, establishing the roles. Let's just dive right in by clearly establishing the two main characters in this bidirectional conversation. So, the entire web is built on the client-server model. The browser, the actual software you're using right now, is the client. And its entire job is to send a request out into the digital void. On the other end is the server, which receives that request, processes it, and returns a response. Think of your browser as a customer placing an order at a restaurant, and the server as the kitchen that builds and delivers exactly what you ask for. The internet is essentially just trillions of these tiny ask and receive transactions happening all at once.
Moving on to Section 2, the split-second journey, slowing down time. Let's examine the microsecond by microsecond sequence that happens when you actually try to access a page.
Okay, so before sending anything, your browser first dissects the anatomy of the URL to know exactly who to talk to and how to connect safely. A URL isn't just a name, it's a highly structured set of instructions. The scheme, like HTTPS, dictates the protocol for safe encrypted transit. The host or domain is the actual server name, and by the way, this is exactly where attackers love to swap in lookalike domains for phishing. Then we have the port, which is the logical endpoint on the server, usually port 443 for HTTPS. Following that is the path, pointing to the specific resource, and occasionally a query string containing extra parameters. Basically, your browser rips this URL apart instantly to build its navigation plan. Once it reads that URL, your browser kicks off a sequential flow. First, it checks the domain name system, or DNS, to translate that domain name into a numeric IP address. It then opens a network connection to that exact IP. Before any actual data is exchanged, assuming you're using HTTPS, of course, the browser and server negotiate TLS encryption. They establish a secret handshake so nobody can eavesdrop on the transit. Only after all that does the browser send its HTTP GET request. The server processes it, returns the status code in HTML, and finally, your browser renders the page, applying all the CSS and JavaScript. All of these steps fire off in a fraction of a single second. It's pretty amazing. Section 3, static versus dynamic content. What exactly is being served? Let's see how the server decides what kind of content to send back across the network to your screen. Just like our restaurant analogy from earlier, the server really has two main ways of fulfilling your order. Static content is like grabbing a prepackaged snack from a display case. It involves things like basic HTML files, logos, or images that the server just sends exactly as they sit on the hard drive. Literally nothing changes. But dynamic content requires the kitchen to custom make a meal after checking your specific dietary database. The server has to verify your authentication, read a database, run application logic, and generate a totally unique page on the fly. So when you load your bank account balance or, your social media feed, you're requesting dynamic content. Finally, Section 4, behind the scenes, complexity, solving web amnesia. This is the final part of our explainer where we look at the hidden mechanics required to keep your dynamic sessions secure. The absolute crucial point here is this massive technical hurdle. HTTP is stateless. That means each request is completely independent. The internet effectively has the memory of a goldfish. It treats every single click, every single image load as a brand new isolated interaction with absolutely no built-in memory of what you did 3 seconds ago. Obviously, a web with amnesia would be a total nightmare. You'd have to log in with your username and password every single time you clicked a link. Web applications solve this stateless amnesia by using cookies, sessions, or tokens to create continuity. To stop you from having to log in constantly, servers give your browser a session cookie. Think of it as a VIP wristband or a memory token. Once you prove who you are the first time, your browser just quietly flashes this digital token back to the server with every subsequent click, basically saying, "Hey, it's still me, let me in." Because these cookies act as the actual keys to your digital identity, they are incredibly powerful and honestly, they must be guarded tightly. If an attacker steals your session cookie, they can completely impersonate you without ever needing your password. And this is exactly why developers attach strict security flags to them. The secure flag ensures the cookie is only ever sent over encrypted HTTPS connections. HTTP only hides the cookie from malicious JavaScript trying to snoop on it. Same site prevents cross-site request forgery. And of course, proper session expiration protocols ensure that if you walk away from your computer, your session doesn't just stay active forever. Bringing it all together, a seemingly simple login page relies on this entire anatomical stack of technologies just to safely serve you dynamic content. You have TLS encryption, protecting the traffic in transit from eavesdroppers. You have password hashing, securing the server-side database so even the website owners don't know your actual password. You have the database securely storing the user records, and multi-factor authentication providing a secondary, stronger layer of identity verification. It is a brilliant, layered architecture. Which leaves us with a provocative thought to end today's explainer. We've just mapped out the incredible, invisible, split-second journey of a single web click, from DNS translation and TLS encryption to dynamic database generation and session cookie validation. If you were a cybercriminal looking at this massive chain of interconnected events, which link would you try to break? Would you go after the human with a phishing URL, maybe intercept the unencrypted traffic, or try to steal the session cookie? Think about that vulnerability the next time you browse. Thank you for joining me, and keep questioning the technology around you.